Okay, a new adventure. Here we go. So here's our problem, tangent squared x plus tangent x equals 0. Oops. Here's our flow chart. Write all terms as variations of sine, cosine, or tangent. Check mark. Okay, done. Does this new equation have a squared trig term and a non-squared trig term? It's taken us this long, but yes, a squared trig term and a non-squared trig term. So we get to go down this path. I chose the path less traveled. So what do? We set the equation equal to 0. Oops. Check mark. Then what do? We factor. Okay. How do I factor something that looks like this? We've talked, now think back to when we were doing our simplifying and verifying, right? We always said look for plus or minus signs. And then on either side of the plus or minus sign, do those two terms have anything in common? In here we would say yeah. They both have a tangent x. So we're going to take tangent x and factor it out. Okay? Now, if I factor a tangent x away from tangent squared x, again, I know I've shown you this many times, but this is really that, which is really that, right? So tan squared x is really tan x squared, and tan x squared is really tan x tan x. So we're factoring out a tan x from that. We are left with a tan x in its place. When I factor tan x away from tan x, I'm dividing that tangent x out. And we don't say there's nothing there now, we say that there's a 1 there. So we have factored that expression. Right? We didn't get binomials, and that's okay. If you're like, where's the other binomial, the two parentheses that I'm supposed to be multiplying? That only happens when we have a trinomial. We'll see that in the next example. Okay? So in this example, we just have this statement. So, factor, done. Now what? Set each different quantity equal to 0. Set each of the factors to 0. So that means set this equal to 0. And then separately, set this equal to 0. That's called the zero product property. We did that a lot back in Unit 2 when we were finding the zeros of a function, where we had to do a lot of factoring. We did synthetic division. I don't know if you guys remember that, but we found a zero by graphing, and then we did synthetic division, and then we broke it down, and then we had all these different factors, and we set them all equal to 0 separately, and found those values. Same idea. Okay. Now we got to ask ourselves, because we don't have the process of looking at the unit circle to help us do our tangent problems. Okay? To do our tangent problems, we just got to know the angles. Now, I think when we went through this, and in fact I'm going to come over here to the board. When we went through this, we said that we needed to know 3 tangents. You needed to know the tangent. Any tangent of pi over 6 was going to result in radical 3 over 3. Any tangent of pi over 4 was going to result in 1. Any tangent of pi over 3 was going to result in radical 3. We never talked about 0. Okay? And I'm not going to push the limit here right now, based on what I'm seeing in the audience right now. Oops. Pretty simple, this one. The tangent of 0 is 0. So a radian measurement of 0 produces a tangent value of 0. Okay? And in fact, you know what? I am going to push the envelope a little bit. Why? When you think about the unit circle and you look at the first quadrant, this ordered pair is 1, 0. Right? We have the first quadrant, the 45-degree angle is radical 2 over 2. Right? This point up here has coordinates 0, 1. I am gonna draw it back, because why not? When we do tangent using the unit circle, we do the y coordinate over the x coordinate. So the tangent of 0 radians is y over x. And y over x is 0. So, when you're doing this problem and you have to ask yourself, what angle produces a tangent value of 0? The answer is 0. I know it's weird to say that, but that's how tangent works. Alright? Now when I solve this one, I have to isolate the trig term. So I have to subtract the 1 over to the other side, and now I have tan x equals -1. Well, that's one of the values we're supposed to know. Pi over 4 angles have tangent values of 1. However, you're like, oh my god, however, you jerk. You're always trying to screw us up. Tangent values are negative in specific quadrants. And I've shown you guys this before. Okay? Tan x is positive in quadrant 1, negative in quadrant 2, positive in quadrant 3, and negative in quadrant 4. So when we're asking ourselves what angles have a tangent value of 1, we know that they are pi over 4 angles, but specifically for this problem, they're the pi over 4 angles in quadrants 2 and 4, where tangents are supposed to be negative. So these outputs are specifically 3 pi over 4 and 7 pi over 4. I don't know why the font got all wacky there, but there you go. Raising our game a little bit here, right? We had to factor it, then we're solving 2 separate equations. We had to talk a little bit about tangent of 0. We had to talk a little bit about, again, reviewing where tangent values are positive and negative. A lot going on here, but worth a challenge, don't you think?